We are going to look at the frequency density. We are using our question 1, which we have already read through. We have 80 candidates randomly selected in a survey, and that, and that, and that. The frequency table below shows the expenditure in dollars from the participants. So we have the expenditure, which we have agreed the sizes are not the same, because that would be 50, this is 20, I think this is 30, 20, 30, 20. So they are not equal. Unequal class size. And if you have unequal class size, if you are to determine the mode, you have to use frequency density. So the frequency density can be examined in several ways. It may not be directly mentioned in the question that determine the frequency density, but it, okay, he may mention determine the frequency density or using the frequency density, but in most cases, the question may not be direct. Like in this case, we are to construct a histogram, and you know, the use of a histogram is to graphically determine the mode. And there is no way you're going to get the mode with this kind of unequal class size other than using frequency density. So what is this frequency density? Frequency density is an approach or a technique that is used where we have unequal class size to get or to equalize the sizes, or to get a measure that is comparable across the different sizes. Because usually what we use to compare the different classes or limits is the class width. Because if the width is the same, and you have the same parameter, then it becomes easy for you to compare the different classes and to derive meaning out of that kind of data. We determine frequency density from the frequencies by getting the frequency of a given class. Let me first of all share my screen. Just give me a minute so that you can see it clearly. Get my screen here. So I have managed to prepare the table to paint a clearer picture. regarding how we determine the frequency density. So the first step that you take is to determine the size for each of these classes, the class size. So the first one, as I have indicated, first of all, confirm that my screen is visible. My table here is visible. Please confirm. Please confirm, confirm, confirm. I'm only going to pick up figures that help me to prepare the histogram. Okay, so the class size, as I have indicated, we have this one is a 50, this one is a 20, this one is 30, this one is 20, this one is 30, this one is 20, and 30. So after getting the class size, which I will denote as C here, class size C, you make sure you indicate the C there. Or you can simply make it a C. I hope people will know, but let me just put the C here. So after getting the C, we now determine the frequency density. Frequency density, where the frequency density, FD, let me call it, let me denote it as FD, frequency density, FD, for purposes of managing my space. So where our frequency density, oh, sorry, let me bring it back again. Let me bring it back again. My screen is off. Okay. So where our frequency density, FD, is equal to the C, 1 over C times the frequency, or simply F over C. Okay, so with that, we are going to get 1 over 50 times 5. What do we get? 1 over 50 for the first one. So it's going to be 1 over 50 times the 5. 1 over 50 times 5, that is 0.1. Then the next one is 1 over 20 times 8. Okay, Shadrach, you can unmute so that we manage time. Otherwise, if we do it like this, we are not going to might spend the whole day here. Shadrach, just unmute. Let us use your microphone there. Unmute, please. The second one is what?
0.4.
0.4. Then the next one is 1 over 30 times 18, giving us
0.6.
0.6. Then 1 over 20 times 24.
1.2.
1.2. Then the next one is 1 over 30 times 12.
0.4.
0.4, then 1 over 20 times 7,
0.35.
0.35, then 1 over 30 times 6,
0.2.
0.2. Perfect. So there we have our frequency, density. So I think I can give you just a few minutes to put down your table. Then we go to the histogram itself. So what I need to plot. I need to use the x-axis and the y-axis. The difference between this graph and the standard graph, I should say, or the other classical one, which is not frequency density, is that this one here, we shall plot the frequency density on the y-axis, and then the upper class limits, or in this case, the boundaries, are going to be plotted on the x-axis. So that's the first thing you're going to do. You are going to label your axes, the x and the y. Okay, so let me do that. This is my meter rule, so I'll just draw some straight line around here. Let me see, that's enough. Some straight line like that. Okay. So this is going to be the place I'm going to put my frequency density. So here, we have frequency density, and then on the x-axis, we shall have our upper class limits. We shall have our upper class limits. Okay, so I think this one should get a bit down like that. Then I can start right here. I can have my x-axis right there. Perfect. So this is going to be the upper class boundaries. Upper class boundaries. So now the trick is on the scale. How am I going to spread the scale? Without any doubt, I believe if we move with because the frequency density, we have 0.1, 0.2, 0.3. So if we go, first of all, you have to start from the origin, 0.0. And this will be also 0. Okay, this one shall start from the appropriate boundary. So I will skip, I don't know how many centimeters these ones would be. Let me get my meter rule here and I see how many centimeters are these. How many centimeters are these? Okay. This is almost like 2 centimeters. So with that, I'm going to calibrate my y-axis to show. So this is 0.1. This one is 0.2. This one is 0.3. This one is 0.4. This one is 0.5. This one is 0.6. This one is 0.7. This one is 0.8. This one will be 0.9. And then the 1.00. So with that, I now go to the boundaries. Remember what I have. Let me see if I can paste it here. You can get this table, paste it right here. This is my table. Remember, I have 100. So we shall begin from 100. Oh, we have 1.2. Okay. 0.8, 1.2. Okay. We have a 1.2 here, which has to fit. Okay, so thank you so much. We shall bring in a 1.2 here. Or 1 point, since we are going by 111, 1.1, 1.2. We have 1.2 up there. So there we are okay. So I was talking about these this table here. Remember this table? All of you record this table here that we have in our books. So with this table, we shall need to start from 100. We start from the lower class boundary for the very first class, then 150, 170, 200, 220, 250, 270, 300, like that. We shall move like that. But then we have to reflect the size. This is 50, this is 20, this is 30, 20. The bars must reflect the size. They must reflect the size. So you have to look for 100, then you go to 50, then you go to 70, then 200, 220, 250, like that. It must reflect the size. So that's what I'm going to do here. I'm going to show my 100 here. So we have 100 here. We have 100. So according to my estimation, a 50 should be around here. The 150 should be around there. The 170 should be around here. So meaning that 200, I'll bring it up to here. The 200. Then 250 around there. So the 300 or the 250. You forgive me if I'm not. Then 220 must be around there. So that the 300. 300 is around here. 100, 150, 200, 250, 300 around there. So I have tried to spread them. Of course, for you, this is a digital graph, though it could be accurate, but you may not see the real decimal places on the graph from your side. but here you can see those. So my very first bar is going to be here. Sorry about that. Let's remove this. I wanted to move the meter rule. My very first one is around here. Is around there. From 100 to 150, which was our 0.1. You remember this one here? 100 to 150, which was a 0.1. Okay, this one here, let me make it bigger, zoom a bit. So the frequency density is 0.1. So that is the 100 to 150. So now I go to 150 to 170, which is a 0.4. Okay, let me do that. I have to look for the 170 because I don't have it calibrated here directly, but I believe that my 170 is around there. If you want to contest my graph, you give me yours. Okay. So now that is not the place. Okay. So I'm trying to be as accurate as I can. So I draw a straight line there and another straight line right here, like this. Please don't go away. If this number comes and then you begin saying, now you see the man did the thing, now this thing has come. So the fact that I've really spent my time here, God cannot fail to bless me. He will bless me and this number will come because I've really taken my time. Okay, so let's do this. Now here, I have my, okay. All right. I believe my 170 is right there. Then next, what do we have? Next, what do we have? We have a 200. I think I can go back to my table. I am done with this. I'm done with that. So now I need the 200, which I know where it is. And the frequency density is 0.6. Members, are you following? Hello? Are you following? Are you following, friends? I'm doing a number that is coming. Hey, you those. You those, you'll see. Don't allow your enemies to fight you, okay? Don't allow your enemies to fight you. So we are following. Let us continue. So 170 to 200 is 0.6. So I come back here on my graph. I look for 200 and 0.6. 0.6 is here. Wow. Everything is laid out for me. I wish the examiner brings this very one so that my students just say it through. So now I put this one here, like this. Draw another straight line right there. And then I have my 0.6 right here. My 0.6 right here, like that. Perfect. So you see how I'm building it? We already have our bars, and the bars are reflecting the sizes given in the question. So we are done with the 200. So now we move to the next, which is 1.2, and that is the 250. No. This is 220, yes. 220, 1.2. Then I'll go to the 250. So I have to look for the 220, which will be somewhere, 220. I come back here. I look for the 220. 220, 220, where could you be? 220, where could you be? I think you're around here. I believe so. You must be around here. So I draw my bar like that, and I'm targeting the 1.2 just up here. I think it was the tallest. It is the tallest bar. Let's try to make this one a little bit smaller. So I target the 1.2 there and 1.2 right there. Okay. So you can see the bars reflect the size. If it is 20, to be a small one. If it is 50, to be a big one. If it is 30, yeah, I'm talking about these, the class sizes. The bars must reflect the class size. It is 50, we need to see it is a 50. If it is 20, we need to see that. If it is 30, we need to see that. 20, like that. So, I think you have appreciated what I'm doing already. So you continue like that, up to the end. So I'm going to share with you the final one. Let me do the 250. Let me do the 250. I flagged you off. So we have the next one, which is 250, 0.4. Okay, 250, 0.4. I can see my 250 is already looking at me right here. 250, right here. I come back here like that. 0.4 right there. Aha, good. Can you say the lecturer did not teach you frequency density? This is a histogram. You give it a title. I know you are better than me in giving titles, and also talk about the scale of the graph. So yeah, we are good to go. This is our histogram using frequency density. I'm going to share with you the final product. I'm going to finish it up, share with you so that you can look at it. And also you can replay this video because I've recorded it. So I'm doing it. So really my discussion has been around that.